I didn't get an official okay. All right, everybody. Welcome to my session. My name is Jason Plurad. I'm a software engineer at IBM. I work in an open technology group, so what we do is we go out and see what's out in open source and see how we can apply it to our IBM software services and products. I've been focusing in the data space for my time on this team, most specifically in graph technology, so graph databases, graph analytics, but I do get involved in other types like big data, Hadoop, and NoSQL. And also a PMC member on Apache TinkerPop. So today we're going to be talking about Apache TinkerPop and how it can enable a multi-model graph. Because of the way that TinkerPop was architected, it gives you the right types of constructs to build a unique graph solution. We'll take a look at graph strategies and how, as a implementation of the TinkerPop stack, you can implement your optimizations to speed up queries and make them work against your backend of choice. And we'll look at many of the providers in the TinkerPop ecosystem. So Apache TinkerPop, are people here familiar with Apache TinkerPop? Okay, well, not too many. So Apache TinkerPop. My story doesn't go as far back as Emil's with graph computing. We started looking at open source graphs probably around 2012. This was the same time when social graphs were really picking up steam with Facebook, Twitter, LinkedIn. And we saw this as an area that was going to explode, especially with Google starting to roll out its idea of a knowledge graph. So we immediately went out to the open source to see what the latest and greatest stuff was. And as we evaluated different graph databases that were out there in the wild, like Neo4j, we found that they were all pointing back at the same stack of TinkerPop. And researching into that, we find that TinkerPop was established in 2009 as an open source vendor-neutral project to do graph computing. It provided the base infrastructure for constructing a graph query language called Gremlin, and lots of other nice pieces to build a full solution. It falls a little bit short in terms of defining a graph database, as we can see in this picture. And the goal there is to really attract different vendors who want to implement that layer, but providing them with the right set of tools and interfaces to do so. And this is really one of the largest things that appeals to me as a software developer. There are plenty of different ways to contribute, and there are definitely many interesting problems in the space that need to be addressed. And given the community involvement and excitement, it's a good place to contribute. So as we continue to get involved with Apache TinkerPop, we worked with Marco and the rest of the TinkerPop team to bring them out into the Apache Software Foundation, so that way we can get a nice solid home for all companies with proper protections, IP protections, and legal protections to collaborate on a core graph infrastructure. So next we're going to take a look at multi-model graphs. This is also referred to many times as polyglot persistence. It's the idea that graphs are never alone in your data architecture. I mean, graphs sound really great on paper. It's whiteboard friendly. It's easy to link together different types of data without requiring a schema update. But at the end of the day, why would we need more than one database, right? I mean, why don't we just put it all in the graph? Well, first of all, you probably have a lot of data already laying around in a relational or some other data store. So a common approach that we find from developers is that, well, let's just leave that data there. It works. It's already powering some service. Let's just pull out the graphy parts and stick that into a graph. Another aspect here is that graph databases are still new, really new, and they're still a very small portion even of the NoSQL market. So there's probably a skills gap there. I mean, you need time for people to get more familiar, more comfortable with the idea of modeling your data and querying your data in a graph. out of the gate, one of the first multi-model type of databases is OrientDB. We have Luca Guruli here from OrientDB. He's the CEO, and he was one of the first implementers of the Apache or the TinkerPop stack. And they really embraced this idea of a multi-model database where you have a single store that has the capability to do relational type of queries, graph, document, key value, all in a single persistence, easy to deploy, easy to query. What they have is an extended set of SQL with extensions so you can do more of the graphy type of operations. But very recently, in November, in fact, the power of the open community has come to the rescue in terms of uplifting their stack to the latest versions of TinkerPop. And they've pulled in contributions from developers in open source to enable TinkerPop 3 with OrientDB in their latest version. And that's great that I can mark it on there with a powered by Apache TinkerPop as a multi-model database. So that's one approach. You got a single persistence layer for a multi-model. But the other trend that we're seeing is the idea of reusing existing storage technologies as your ultimate backend. So whether it's a relational database, a columnar store, being able to leverage the capabilities of a modern or other type of data store based on your specific application needs. The great, perfect example of this is DataStax's Enterprise Graph, based on Apache Cassandra. Being able to take advantage of Cassandra's horizontal scaling capabilities proved to be a great fit for graph technology. And they've recently, and I think over the summer, this past year, they released the first release of DataStax's Enterprise Graph in their 5.0 product. It is also powered by Apache TinkerPop. It has a commercial license, but I think that's available to developers to play around with. So those are two different approaches to doing multi-model graphs. So how does Apache TinkerPop get involved here? It comes down to how do we take a graph kind of query and understand how to optimize that query and turn it into something that we can execute against your backing store. So in TinkerPop 2, the different aspects of TinkerPop were broken into separate pieces. They had blueprints for the core graph API, there was pipes for the connecting steps, and then the Gremlin, the traversal language. TinkerPop 3, all these concepts started to meld together into one kind of big blob, and now everything is a traversal, and Gremlin is basically everything. You do everything as walking through the graph. So up here, we've got some of the key terms as we talk about the Gremlin machine. The traversal it's a directed walk across your graph. It describes how you start from one point and locate the information you're looking for in your graph. So we're going to talk a lot about graph traversals. This is nodes, edges, and properties. But you can easily create a traversal which is specific to your domain. So for example, if you wanted to create a social traversal, you can define, instead of having nodes, you can have, say, people, and your relationships, instead of being labeled edges, they might be like a friend or a colleague. And then you can, by using steps are the logic, the computation logic as you go through a traversal. You define steps, and what a step does is it takes in one object and can transform it into something else. So as we step through a graph, there are 5 different types of steps. You've got a map step, you've got a filter, you've got side effects, and some others. This defines how you're going to do your computation as you traverse through the graph. You can chain them together. They can get unbelievably long and complicated. Out of the box, TinkerPop ships about more than 50 steps, and those form like the basis of what you would need to do to create a graph type of application. Traverser, these are the things that actually run through the graph. They're depicted here as little Gremlin characters. So you can think of this as basically your state. As we go through the graph, the traverser keeps track of where it is and its path history, and keeps track of other objects in memory to help you do some sort of computation. But ultimately, it comes down to the traversal strategy, where we can start simplifying that walk through the graph into something that compiles down at execution time. So what we can do is, with this explain step, we can start looking at taking a Gremlin query string and boiling it down into the actual compiled steps. On the left side, we have a list of out-of-the-box traversal strategies that come with TinkerPop. In the center column there, it's a little bit hard to see. That describes the type of traversal strategy. There are 5 different types, and we'll go into those later. But on the right side, we can see the specific step plans. So as we go down through this execution plan, we can see how, when a traversal strategy starts to get applied, our steps become a little bit simpler. And simpler is better when it comes to execution time. So now that we understand a little bit about what a traversal strategy is, there are also some optional type of strategies that you can add, and you can do that with strategies as you create your traversal sources. So here, this is an example of adding an event strategy to your traversal. We create a mutation listener and register that with our graph traversal, and then as we start mutating our graph with adding vertices or dropping them, we can see some of the action that's going on. So I mentioned before that we've got 5 different traversal strategy types. They're categorized by how they work and the order that they're executed. We're going to step through these one by one, and then essentially the traversal strategies are executed at compile time, and these form the foundation of the Gremlin traversal machine compiler and the optimization. So a decoration type of traversal strategy, these are application level types of things. We showed before the event strategy, and that's a good way for looking at mutations. Another interesting one is the partition. So this would be a way to, say, label some of your data as you bring it into your graph. What it does is it sets a private property on the data and labels it as coming from a specific type of domain. So what you can do is you can restrict traversals to a specific partition. Similarly with subgraph, you could try to read only a portion of your graph as opposed to exposing the entire graph to your user by restricting by labels or other properties to define what specific pieces of the graph you want to expose through a read operation. Skipping over the optimization types, we're looking next at finalization. These come near the end where we're trying to make any final adjustments to the traversal before executing it. The match algorithm, the match step itself is TinkerPop's way of doing more declarative style of operations. So in the traditional usage of Gremlin, you do more of an imperative style where you define exactly how you want to navigate through your graph. With a match step, you set a bunch of parameters such that you can decide the different subpaths that you want to traverse through. This can break down into 2 different approaches as you try to match against different steps. By default, we try to prioritize the steps that will reduce the number of traversers in your traversal as much as possible. The fewer traversers that you have running through, the less memory you're going to take, the faster it's going to go. Profile step is another interesting one. This is how you can keep track of your overall performance of a query. So what it ends up doing is it adds a profile step onto each step within your traversal. So that way we can keep track of the number of traversers at that specific point, how long that step took to run. It's a great way to keep track of potential bottlenecks in your queries. Verification, so this is at the very end, this is making sure that you're not doing anything illegal at compile time. So This could be either based on the Gremlin syntax or on specific application restrictions. So for example, lambda restriction. TinkerPop is written in Java, and it allows you to provide functions, essentially, where you can do whatever you want with the objects at every step. But in a shared environment, or if you're running TinkerPop as a service, this may not be something you want to expose to your end users. That whatever code is happening in that Lambda, it might not be something safe or secure. So you can just, with the Lambda restriction traversal strategy, you can just eliminate those and prevent those from occurring. Read-only, let's say if you just want read-only access, similarly, this helps to reduce your attack surface from unwanted traversals. Optimizations. So this is how we start to look at how to distill down a Gremlin query into a more succinct description of what it's going to do by only using TinkerPop steps. And this is a subset of what's available, but it starts to make a little more sense when you're using Gremlin, because there's just a variety of ways to describe the same exact traversal in Gremlin, which is good and bad. But it's nice to know at the end of the day, given the traversal strategies, these optimization strategies, that if I write it one way and you write it another way, that by going through the traversal strategies and understanding how the optimizations come into play, that we're actually still doing the same exact thing. So a lot of these are pretty simple, such as like these first two. So for example, just if you're trying to count incident edges, you don't need to traverse all the way out to the vertex at the other end. You're going to save yourself a lot of cycles by just going to the adjacent edge. The path retraction one is also a very interesting one. It was written by one of our committers who's speaking later today, Ted Wilmes. And what this does is it allows you to shed unnecessary path information. So as I mentioned before, as your traverser goes through the traversal, it keeps track of that path history. But if ultimately you're not using that in the result, there's no reason to keep it around. It's just going to take up a lot of memory and unneeded space. So being able to pull out that information helps speed up your traversals immensely. So this is where vendor-specific TinkerPop backends really come into play with provider optimizations. This is how different backends have the opportunity to custom tailor Gremlin and the traversals into something that they can use. So we're going to take a look at other providers in the ecosystem. So first up is SQLG. This is written by Peter Martin, who's a Apache TinkerPop committer. It presents Apache TinkerPop graphs on top of a relational database. It has several different relational databases that are supported. And what it attempts to do is optimize Gremlin by reducing the number of calls to the relational database. So what it does is it goes ahead and looks at all your steps, all the out traversals and edge traversals, and tries to combine those such that it can build up a multi-line inner-join SQL statement. And that's really the magic behind it. If we look at the execution plan here with the explain step, you can see that we've got a SQL graph step and a vertex step. This is a pretty common pattern as we look at different TinkerPop providers. Having a graph step and a vertex step, that's really the main starting point for building out any optimization. So we'll notice here that these SQLG strategies are actually at the top. They're ahead of where they're supposed to be in the order. And I think this is specific to the relational case where they needed to make sure that the those inner joins happened as soon as possible before anything else happened on the traversal. Next up is TitanDB. TitanDB was written by a graph consultant firm called Aurelius, who later were acquired by DataStax. They had been working with Pearson Education to create a scalable graph on distributed backends. At the time, this was 2012, and there was no such solution in the market. And it was well designed in that it allowed for different backends, both in terms of storage with Apache HBase and Apache Cassandra, and for indexing backends with Elasticsearch and Solr. And another key aspect of TitanDB that we found particularly interesting is that it was one of the only databases that was able to bridge both OLTP type of traversal and OLAP. And so being able to do large graph analytics on Hadoop over MapReduce, which was still a thing in 2012, that was an attractive package, having a horizontally scalable, very customizable type of distribution.
Is it not dead?
We'll get to that. I mean, DataStax released Titan 1.0 in November 2015. They got acquired by DataStax in February, so TitanDB made it out after they were acquired.
But no activity.
Yeah, we'll continue talking about that in a bit, but right. Development had slowed down significantly after that 1.0 release, and we'll get more into that later. But it's all out there, and we can see through its strategies, it has similar strategies to SQLG, but it's more geared towards the columnar store backends. A key part that I hadn't mentioned before about Titan is that it has a solution to the supernode problem, the Katy Perry highly connected node. And its approach is the idea of vertex-centric indices. And what that ends up doing is sorting on a per vertex basis the incident edges based on label and other properties, such that you can traverse through that supernode a little more intelligently without having to scan through hundreds of thousands of edges. So as I mentioned, in 2015, Titan 1.0 was released. Even though development on the core Titan had slowed down a bit, interest in Titan continued to increase. In the year since it got released, it had doubled in stars on GitHub from 2,000 to 4,000. And we saw 3 different backend storage providers come into play. We had DynamoDB from Amazon, we had an embedded store called Tuple, and we had ScyllaDB come into play. ScyllaDB, if you're not aware, it's a drop-in replacement for Apache Cassandra 2.1. It's implemented in C++ with an I/O scheduler and async operations for higher throughput and low latency. So it offers a very intriguing value proposition. The one wrinkle we did have with Titan is that Scylla out of the gate did not support the Thrift interfaces, which Titan, since it was developed so long ago, was coded against Thrift as opposed to the CQL native interfaces. So over the last summer, we worked with the Scylla team to validate that Titan did work as they rolled out their Thrift support. And as of Scylla 1.3, Titan works with Scylla. And in my company, IBM, we have many offerings of NoSQL databases as a service if you don't want to stand it up by yourself and not worry about those type of deployments. So we're offering Scylla as a hosted database offering on IBM Compose. And if you hadn't had enough hosting, IBM Graph fills the rest of the gap. So if you were to go with IBM Scylla or IBM Compose and Scylla as hosting for your main persistence, you would still need to stand up the Titan server nodes and manage those. But if you don't have the skills in-house and you'd rather not worry about that, we have IBM Graph as an offering in IBM Bluemix. It's a fully managed Apache TinkerPop compatible OLTP graph database service. So you can really focus on modeling your data, getting your data into a graph, and just running it without having to stand up, different sets of clusters and managing that 24/7. Which, if you've tried to do it, it becomes more than a full-time job. And so that's available right now on IBM Bluemix. You can register with Bluemix for a 30-day trial. We have our developer, some of our developers here. Allah is the graph lead, and he'll be speaking at 2:50, which is actually the same time as Dor. I had forgot to mention him before. Dor Leor from the Scylla team is also here. He'll be speaking about Scylla DB at the same time. So what's on the horizon for the TinkerPop ecosystem? More providers. Unipop, this is an interesting one. This is a data federation platform that they're trying to do virtual graphs on top of Elasticsearch. They have a JDBC connector too, but I think Elasticsearch is the more interesting one. You can treat Elasticsearch like a document data store with indexing, so it's a pretty cool value proposition. It's developed by two guys out of Israel, I believe, Sean and Ron. They've been around TinkerPop for a while, and it supports TinkerPop 3.2, I believe. And it has a lot of the same thing, traversal strategies to work with their preferred backends. At the ASF, we've got Apache S2 Graph. I met with these guys at ApacheCon last year. This is a graph database project that came out of Korea. Kakao is the largest mobile messaging app in Korea, and they're using S2 Graph to power over 20 production services. It's built on top of HBase, Apache HBase, and Scala, and they're incubating over at the S2 Graph. They're looking for new contributors, and the first thing I told them is, if you guys can get TinkerPop support, with the development on Titan slowing down a bit, it could be an opportunity for you guys. And they seemed real excited by it. They immediately opened up their Jiras and been hacking away at it. They're not quite there yet, so I don't know. You can't really see it, but I actually had to dim down the TinkerPop logo on there. But that should be coming soon, getting TinkerPop support with S2 Graph. This is a new player, very recent, HGraphDB. It's TinkerPop on HBase. It's written by Robert Yokota, and he's a developer out of Yammer. Yammer is an enterprise social graph application. They got acquired by Microsoft several years ago. So he had a survey of the graph landscape, and he's a believer in Apache TinkerPop, but the existing solutions didn't quite work for what his goals were, and user supplied IDs and being able to do giraffe without using a Spark graph computer. So this development only started in November, I believe, and he's done a lot of work in the past 2 months, and I think this is really just a testament of how simple it can be to build an Apache TinkerPop enabled graph system on your system of choice. It doesn't necessarily need to be generic. You can custom tailor it to your specific needs. So this is an interesting one to keep an eye on. It's written by just one developer, so I think that's amazing. Then finally, on Thursday this week, the Linux Foundation announced the creation of the Janus Graph project. This represents a fork of the Titan DB code. So as we had mentioned before, the Titan community had stalled a fair amount, and the interest in Titan didn't go away. So we were able to find other people who were interested in supporting Titan to continue on in an open fashion with vendor-neutral community. So IBM, together with Xpero, Grokken AI, Hortonworks, Google, we worked with the Linux Foundation to create Janus Graph, and it was announced on Thursday. A lot of the members, many members are actually here, which is very cool, having a graph specific event. Ted Williams, who's also on TinkerPop, he has a session later today. Haikal Prabhati from Grok and AI, he's the CEO and founder of that graph solution. He has a session later. So, I mean, there's nothing but excitement around the TinkerPop stack and what we can do together in an open source community together. So, I mean, in closing, I think we have a lot in the open source graph community, a lot of thanks to give to the Aurelius team and the crew there. So that includes Marco Rodriguez, Matthias Brokler, Stephen Millett, Daniel Cuppets, Dan LaRoque. Their contributions to the open source graph space has been amazing, and their impact continues to grow. And thanks to organizations like the Apache Software Foundation and the Linux Foundation, I look forward to a lot of new developments in this space, and just hopefully a big snowball effect as more and more companies and individuals get involved in pushing the industry forward. I mean, I think we can all agree on, there's plenty to do in the data space, and the best approach is to work together as a community in the open. And finally, a shout out to Katrina Yim. She's a TinkerPop committer. She's a graphic artist, and she did all the icons for TinkerPop. And I think that just goes to show that there's plenty of ways to contribute to open source. It's not just code. Documentation, graphics, testing, doing events. There are plenty of ways to contribute to open source to help spread the word about all the great things that are out there, and celebrate the people involved. And with that, thank you. IBM, we have a firm commitment to this idea of open by design, by really embracing the open source community and becoming part of it to help, as an industry, move the bar higher. And with that, I think that's about it. Any questions?
So the keynote, you heard that Cypher is going to become, certainly there's an equal number, if not a powerful lobby for Gremlin. And so this issue or challenge of really deciding between Sparkle or Gremlin or Cypher still remains for most of us. So what is your view on that, given what was said there?
Okay, that was a great question. So the question was around Open Cypher and its goals, and where does that leave us as graph enthusiasts when we have multiple languages to choose from? So I've got plenty to talk about here. I don't necessarily want to bore all of you, but when we first started doing property graphs, we got immediate feedback from people saying, hey, wait a second, we've got RDF. What are you doing property graphs for? And now, with Cypher coming into popularity, people are, obviously looking at both. Neo4j has done a great job in terms of promoting graph technology. And OpenCypher, it is Apache licensed, and that's a fantastic thing. And but the problem that I see currently with OpenCypher is that it's controlled completely by Neo4j. It's not under open governance like many of the projects I talked about today, under the ASF or under the Linux Foundation. So that means they completely control that. And if you go out to their website, it clearly says, hey, this guy, I forget his name, he's our benevolent dictator. He's the bottom line of what we do for Cypher. So that really doesn't really promote an open conversation on how we as a graph community can push that forward. But that being said, it is Apache licensed, and if we can continue to work with them and understand how their AST, their abstract syntax tree, can compile down into Gremlin, we can still support that in the TinkerPop ecosystem by converting Cypher into Gremlin steps and then going through our normal traversal strategies. So it could be possible that you can have your cake and eat it too in the future. But like I said, getting OpenCypher into a more vendor-neutral, open type of community, I think that for me, that would be the most important first step. Thank you. That's a great question. Any other questions?
Yeah, do you have like partitioning strategies for like cluster, like, how does that, affect your traversal?
Yeah, that's actually an interesting topic. I mean, there's been a lot of recent movement currently in the TinkerPop community, like within the last month or two. They've been evaluating how to do that type of partitioning in a multi-node cluster. There's a new, if you go out to the Google groups, Gremlin users, you can read more about what's going on in that space. We're looking at something we're calling graph actors based on the ACA framework. And that appears to be something that we can use to get us more away from the idea of vertex programs. That's our existing strategy for doing OLAP. With the graph actors, it becomes a little more, let's say, fluid in terms of being able to bridge that gap between OLTP and OLAP. So I think, going forward, I think we can address that better. So I think that's the direction we're going in, and it'll be an interesting year and see how that comes out. I mean, right now, I think that'll probably be on the radar for 3.3. I don't think we have a timeline spec'd out for it yet, but it'll be a pretty significant release. Questions?
Do you know who's going to be the winner of all this? We were waiting for last couple of years, right, to figure out, who's going to come ahead in this.
Yeah.
Then a new is a little bit, but they're more towards the OLTP side, and most of us here are on the OLAP side. And even with the we don't. I mean, Spark is there, but it changes so much. It's very difficult for enterprises to adopt it very well. And we just need something like an OLAP which we can, put against. Maybe Titan was that, but it's just not very good.
Yeah, the question was who's going to win. I mean, obviously, I can't say. I have no idea. If I knew, I would be making sure I was working for them with options. But yeah, I mean, I understand that tension. I mean, obviously, the appeal of graphs is that you could throw a bunch of data at it. And OLTP works for some cases, but the majority of cases, you need that whole graph type of operations. And as you said, in the Spark space, with graph frames coming out, pretty much displacing GraphX, it adds a lot of confusion. And with TinkerPop having a Spark graph computer, and now this new approach, I mean, I think we're still trying to figure that out. So I don't think we're going to find that out in 2017, if I were to guess.
Being in Apache does help because at least we can try it out and figure out whether it works or not. And then, that helps instead of getting committed to a license and not having to.
Yeah, and like I said, I mean, that's the beauty of open source, just being able to get out there and try it, because I think the best ideas are still to be found, and going proprietary, I think that's just a bad choice. Because if somebody has that crystal ball, I don't know what they were waiting for. They should have done it 5 years ago. I think we're out of time. If you guys want TinkerPop Gremlin stickers, I got some. Come meet me. We have an IBM booth if you want to talk IBM Graph or open source. Great to see you. Enjoy the rest of the conference.